This question expected us to solve a system of two linear differential equations by method of Laplace transform. So let's discuss the solution step by step. So we have x prime plus x plus a half y prime equals to 1 and a half x prime plus y prime plus y equals to 0. And the initial conditions are x at 0 is 0 and y at 0 is also 0. Now, the first step will say, let capital X of S be Laplace transform of X and capital Y of S be the Laplace transform of Y. Then we know that the Laplace transform of X prime Laplace transform of X prime by definition will be S capital X of S minus X at 0, which will give us S capital X of S, because the value of X at 0 is just 0. And the Laplace transform of Y prime by definition is Y Sy of S minus Y at 0, which just be S capital Y of S, because the value of Y of 0 is 0. So let me call this system 1. So taking Laplace transform on both sides of 1, we get S X of S minus X of 0 plus capital X of S plus S capital Y of S divided by 2 minus Y at 0. I'm just writing the expressions for the Laplace transform of Y prime equals to 1 over S. So remember, Laplace transform of 1 is 1 over S, and S capital X of S minus X of 0 divided by 2 plus S capital Y of S minus Y of 0 plus capital Y of S is given by 0. I've just replaced these values I've defined here into these given equations. So on simplifying, we'll get S capital X of S, for this is 0, plus capital X of S, and then plus, this is 0, so we just have S capital Y of S divided by 2 equals to 1 over S. So that's from this first part. And then the second part, we'll have S X of S divided by 2 plus S Y of S, because this is 0, and then plus Y of S equals to 0. So this is a simplification of this part, putting in the initial conditions of x at 0 and y at 0. So let's now put these first two terms together. So we'll get s plus 1 capital X of s plus s capital Y of s divided by 2 equals to 1 over s. And then this other one will have s capital X of s over 2 and then plus s plus 1 capital Y of s equals to 0. So let me call this one common 1, or this one 2. Now from 2, we have, so just make capital X the subject. So we'll have capital X of s is given by minus 2 into s plus 1 over s multiplied by y. So I call this one question 3. So remember, I'm simply taking this one to the right-hand side and then dividing through by s plus 1. So this is what you have done. Multiply everything by 2, so we'll have 2. To multiply everything by 2, you have 2 into s plus 1 capital X of s equals to s 2 over s minus 2 minus s y of s. So putting 1 over s and then s have 2 minus this over 1 s squared. So remember, we are using this second equation, not the first equation. So this is this expression from the second equation that we are easily obtaining this expression here. So you now so this was obtained from this equation here by simply multiplying through by 2 and then dividing through by s. So remember, we have specified that this is from 2. And then replace 3 in 1 to get, so where there's x in 1, we put this expression here. So I'll have negative 2 into s plus 1 over s y of s plus s capital Y of s over 2 equals to 1 over s. And then remember, in the first equation, there's a factor s plus 1. So we also have multiply this one by s plus 1. So which will give minus 2 s plus 1 squared over s capital Y of s plus s y of s divided by 2 equals to 1 over s. So this can be written as minus 2 into s plus 1 squared divided by s plus s over 2. And then you factor out capital Y of s, which is 1 over s. Now put this over the same LCM. So 2s minus 4 into s squared plus 2s and then plus s squared multiplied by y of s equals to 1 over s, which when open you get minus 4 s squared minus 8s minus 4 plus s squared divided by 2s. You multiply by y of s, you get 1 over s. Now multiply both sides by 2s and we'll have minus, actually this will give us minus 3s squared minus 8s minus 4 multiplied by capital Y of s to give 2, because now we're multiplying by 2s. So that has been obtained by this computation, 2s and then times 2s. So this and this cancels out. Now we can factor out a negative and have 3s squared plus 8s plus 4 y of s equals to 2. So which is the same thing as 3s squared plus 8s plus 4 y of s equals to minus 2. And this is a quadratic expression. Product is given by 12. Product is 12. And then sum is 8. So numbers, we have 2 and 6. So when you rewrite this term, we'll have 3s squared plus 2s plus 6s plus 4. When you factorize this, you get s into 3s plus 2 plus 2 into 3s plus 2. So we have s plus 2 and then 3s plus 2. So therefore, this means we'll have s plus 2 times 3s plus 2 y of s equals to minus 2. So which means then, making y the subject, we get y of s equals to negative 2 over s plus 2 and then divided by 3s plus 2. Confirm that this can be written as a sum of these two partial fractions, a over s plus 2 plus b over b over 3s plus 2. So which is the same thing as s plus 2, 3s plus 2, and then a into s plus 2, s plus 3s plus 2 plus b into 2s plus 2. So minus 2 is equals to a into 3s plus 2 plus b into s plus 2. So when s equals to negative 2 over 3, then we have minus 2. This part will be 0 equals to b into 2 minus 2 over 3, which will be given by 4 over 3b, which means b itself will be given by negative 3 over 2. And when s is given by minus 2, then we'll have negative 2 is given by a into minus 6 plus 2, which is minus 4a. So a will be given by a half. So therefore, y of s is given by a half over s plus 2 minus plus minus 3 over 2 over 3s plus 2. Which on finding the inverse of y of s will be given by a half inverse of 1 over s plus 2, and then plus minus 3 over 2 inverse of 1 over 3s plus 2. But now, because this term here in the second bracket, this part is not a standard expression, so we divide every term by 3. So the expression 1 over 3s plus 2 can be written as, if you divide this one by 3, divide this one by 3, divide this one by 3, we get a third, and then s plus 2 over 3. So this is the same as a half inverse of 1 over s plus 2. Now, factoring out this a third, we get negative a half. Because we'll have now minus 3 over 2, factoring out the third times 1 over 3. And then the inverse of s plus 2 over 3. 1 over s plus 2 over 3. So since we all know that the inverse of s 1 over s plus a is given by e raised to power minus at, then here we'll get, so this is L inverse of y of t will be given by a half. E raised to power, the value of a is 2, so we'll have negative 2t minus a half. E raised to power, the value of a here is minus 2 over 3t. So this is the value for y of t. Now, to get the value of x, again, from equation 2, we have capital Y of S is given by negative S over 2 into S plus 1 X of S. Now let's call this one question 4. Then replace 4 in 1 to get S plus 1 capital X of S plus S over 2 times negative S over 2 into S plus 1 capital X of S equals to 1 over S. So which, when you put, you factor out X of S, will be S plus 1 over 1 plus, actually minus, because we have a negative sign here, minus S squared over 4 into S plus 1. Then you put capital X of S outside, you get 1 over S. Putting this over 1 LCM will have 4 into S plus 1, and then 4 into S plus 1 squared minus S squared capital X of S equals to 1 over S. So which means now opening the brackets here, we'll get 4S squared plus 8S plus 4 minus S squared over 4 into S plus 1 capital X of S equals to 1 over S. Which is the same as 3S squared plus 8S plus 4 over 4 into S plus 1 X of S equals to 1 over S. And this expression here, product is 12, sum is 8. So numbers, we have 6 and 2. So 3S squared plus 6S plus 2S plus 4. Common here is 3S into S plus 2 plus 2 into S plus 2. So 3S plus 2 and then S plus 2. So here we'll have 3S plus 2, S plus 2, capital X of S equals to 4 into S plus 1 over S. I'll simply multiply both sides by 4 into S plus 1. So this will give us capital X of S equals to 4S plus 4, opening brackets here, S into S plus 2 into 3S plus 2. And this can be written as partial fraction as A over S plus B over S plus 2 plus C over 3S plus 2. Now check that if you do the partial fraction decomposition, you get A to be 1, B will be given by negative a half, and C, you will get negative 3 over 2. Check that. So that capital X of S will be given by 1 over S minus a half times 1 over S plus 2 minus 3 over 2 into 3S plus 2. Now, let's play with this one. So this expression 3 over 3S plus 2, so that the coefficient of S is just 1, we divide every term by 3. So divide by 3, divide by 3, divide by 3. So this will give us 1. So X of S will give us 1 over S minus a half, and then 1 over S plus 2 minus now a half times now 1 over S plus 2 over 3. Now taking inverse Laplace transform on both sides, let's call this one 5. This equation 5, we get L inverse of X is the same as L inverse of a half of 1 over S minus a half L inverse of 1 over S plus 2 minus a half L inverse of 1 over S plus 2 over 3, and this will reduce to 1 minus a half e raised to power minus 2t minus a half e raised to power minus 2 over 3t. Or you can say this is x of t. X of t is given by 1 minus a half into e raised to power minus 2t plus e raised to power minus 2 over 3t. So hence, the solution to that given differential system of differential equations is the solution is x of t equals to 1 minus a half into e raised to power minus 2t plus e raised to power minus 2 over 3t, and y of t is given by a half into e raised to power minus 2t minus e raised to power minus 2 over 3t. So this is how we are supposed to solve that system of differential equations. Thank you.